Alright, it looks like I'm not dropping frames anymore. Hopefully this one's actually live. Yeah, the internet connection looks a lot better. So sorry if you've... Welcome to my YouTube channel. Here you will find information on how to do homework problems. So yeah, sorry if this is... I haven't heard you yet, but I'm still waiting to see myself go live here. Having some OBS problems. But it says I am now not dropping frames and I am live. I just cannot find myself, so sorry if you're commenting. I am struggling to find my own live stream. Oh, technology. Beautiful. There we go. Found it. Mod me. Hello? Hey, okay, so sorry ladies and gentlemen, I've been having some technical difficulties on my end. My sound was cutting out, I was dropping frames. I'm no longer dropping frames, which you can probably see because it's posted on the screen. Yeah. Sorry about the slow start here. Huh. Why was I having issues? I don't know. I updated OBS and that was a mistake because things worked out a little differently and I had to change my wireless and all sorts of different things. So I'm on the right wireless now. And I'm feeling much better about things. Hello, everyone who's here so far. It looks like we got about 12 people. I'm gonna hang out for a second because I got a really slow start here. I was panicking and still had my keyboard attached and everything. No, I don't want tablet mode. It's trash. Alright. What do we got? So I found a whole bunch of extra resources that I've used in the past or that I've found. So I have lots of stuff to talk about today. If people don't give me direction based on what we had, I have different related rates questions. Like we didn't do many of these, I think. No, we did this page, but we didn't do this page. These we did. I have these related rates for response questions, a triangle-y one that has angle and side stuff that I was kind of planning on doing, a cone-related one. We got some variety here today that go above what was just on the review or what was on worksheets or that sort of thing. So, so far, nothing too far. And no, I'm not going to cover Green's theorem. Like that would require me to go to Wikipedia and remember what the heck Green's theorem is, which I do not remember. Let's make sure my volume hasn't cut out. We're chilling. Looks like the stream's good. First question from somebody in the class. It looks like, L'Hopital's review, please. Sure. Okay, so that's where I go into my boy the sketchpad and clear out this garbage from last stream. Okay, so, L'Hopital's rule. If I have like the limit as x approaches 0 of, let's make something that's 0 over 0, so like 6x plus x plus 1 to the 7th minus 1. That's really specific. That looks like a 0 on the top, and what do we got on the bottom? We got like sine x plus cosine of x minus 1. That looks nice. Can you go over the 3 questions from the recent homework that had no right answer? Yeah, that seems good. All right, so this is a L'Hopital's question that would be absolutely horrendous to evaluate without L'Hopital's. It might still be horrendous to evaluate because I just made it up. But yeah, if you plug in 0, you get 0 plus 1 minus 1 on top and 0 plus 1 minus 1 on the bottom. So when we have 0 over 0, we're allowed to take the derivative of the top and bottom independently. If I do that, I get 6 plus 7 plus 1 or 7 times x plus 1 to the 6th power. I still have the limit as x approaches 0. And my bottom derivative is cosine of x minus sine of x now. Now if I plug in 0, it looks like I really don't get 0. On top I get 6 plus 7, because the inside's just 1. And on the bottom I get 1. Cool, so this limit went to 13, which is not probably your first guess looking at this horrendous original thing. And that's the beauty of L'Hopital's. It can take a limit that is really hard to determine and make it really easy to determine. Just make sure not to over L'Hopital's. If you kept taking derivatives of this thing, you would get nowhere. You would get to a bunch of wrong answers, and that'd be sad. On the other end, I might as well do a limit as x approaches infinity before I get to the other questions and that sort of thing. Okay, so an infinity one, x cubed plus x squared. What's a fun function that goes to infinity that we can actually do in this class? Plus x plus 1 to the 4th. I don't know. None of this is that interesting. The infinity ones are pretty boring because they're pretty easy to evaluate as is. So this one, this is how this looks before we do L'Hopital's. We can do a L'Hopital's and get 3x squared plus 2x plus 4 times x plus 1 to the 3rd on the top, and a 5x to the 4th on the bottom. And if you plug in infinity, you still get infinity on the top, you still get infinity on the bottom, so we go again. We could get a 6x plus 2 plus 12 times x plus 1 minus, or x plus 1 squared, all over 20x cubed. And you might notice you still get infinity over infinity, so we take another derivative. And we go 6 plus 24 times x plus 1 over 60x squared, and we still get infinity over infinity, so I go again. And on top, this time I finally get something easy. I get 24 over 120x. And this is not infinity over infinity. All right, sound should be back. I just have to unplug and replug in back in occasionally. Feels bad. Sorry about that. Bro, this stream is low quality. We haven't dropped a single frame. It's just the freaking sound issue. Back to haunt me again. Luckily, I can see it. Okay, yeah, sound cut out, but I finished that question. It was not a super complicated question. It just went to 0. Okay, so Matthew, I'm curious which question is wrong, because I'd love to take a peek at that. I did that review in like 20 minutes, so I probably wasn't super careful. I know I wasn't super careful. Am I inside of a vacuum? No. Implicit please. Okay. It's number 6. Okay. Which one is it? I can look here, I think. Really? I did this one wrong? Is it under 6? That's funny. Okay, well, I can probably do it right now. Whoops, not Sketchpad. If you take the derivative of this, you should get 4 times negative 3x plus 6 with a chain ruled out, negative 3. And you plug in 4, so you get 4 times negative 6 times negative 3, which is 72. Is that not the answer I got? If I made a mistake on that one, feels bad. Rose was sad she didn't do it in 20 minutes. Yeah, feels bad, huh? Oh, I got negative 72. Yeah, that's wrong. It's positive 72. Feels good. Okay, so somebody had question. Oh, yeah, it was on the online, which I should have open, assuming it didn't time out because I took forever. Jimmy asked me about the questions that were wrong, which this was one of them, I believe, if I remember right. So in this question, gosh darn it, I keep clicking on the wrong thing. I don't think I got this answer. So the height of the cup is 12. The opening is 3 centimeters. So our R over H ratio in this one is 3 over 4. Whoops, 3 over 12. That's super trash. Right, I have an eraser. Which is 1/4. So really R equals 1/4 H. And this is what we use in this question. We plug this into our volume equation, so we get V equals 1/3 pi times 1/4 H squared H. If you simplify, or expand this, I guess, simplify, those are the same thing in this context. 1/4 squared is 1/16. It's H cubed here. Now I take the derivative, I get dv dt equals, and I leave the 1/3 there because it always kills with this 3 that comes down. Pi times 1/16 times h squared dh dt. And then I just chuck stuff in here. The depth of the water is 5, so I get 25 over 16 pi as the stuff that's multiplied by dh dt on this side, and on this side I know dv dt is 2, and it's a positive 2 because it's being poured in. And then you multiply the stuff to the other side, and you get 32 over 25 pi, which you may notice is none of those answers. It's closest to 32 over 125 pi, but I'm guessing whoever wrote this question and uploaded it to AP did cubed, even though it's not, definitely not cubed, as far as I can tell. So that should have been the answer to that question. Yeah. All right. The other questions we thought were wrong that seem worthy of consideration is this dude right here. So, okay, it says theta increases at a constant rate of 3 radians per minute. So that's d theta dt. At what rate is x increasing in units per minute when x equals 3 units? So we clearly use our boy tangent here because we use tangent on, I think, every problem we did this year. There are a few cases where you use sine or cosine because the hypotenuse, or, oh man, what are they even? Use tangent most of the time. Oh, is this a case where we could use a different one? Huh. Yeah, actually. I wonder if that's the play here. So I changed my mind. I know about the opposite side and the hypotenuse, so if the hypotenuse is always 5, I'm ready to rock and roll. I can do sine of theta equals x over 5. And that makes life quite a bit simpler. Okay, I take the derivative. I get cosine of theta d theta dt equals dx dt over 5. If you're curious why I use sine, besides just the opposite over hypotenuse thing, it says x is 3, so we know this is 4 because it's a 3, 4, 5 right triangle. So you could totally use tangent without any flaw here. The downside of using tangent is, I believe the 5 thing is the thing that's like static in this, and so you'd have to do quotient rule if you move that direction. So it's possible this one has a correct answer. Who knows? So we plug in 3 for d theta dt. And I need to figure out... Yeah, sorry guys on the sound. I'm a little bummed out about this. It must be something with this headset. I can go to just blank sound. Uh, hmm. So I know I'm back. Well, I don't know I'm back, but I can take a quick peek. Yeah, I'm back. This is an annoying issue, because I don't have this issue when I'm gaming with this headset, so I don't know what the issue is here. Sorry, folks. But I had solved this question. It is actually 12, so this one had a right answer. And the elixir here was using sine instead of using tangent. I think it's possible that a lot of people got this one wrong because they tried to use tangent, but we know nothing about this side, and so they didn't. There was like not less information going that direction, and walking the sine direction was much better. What is an tangent? Good English, Liam. Thanks for that. So that one turns out is very legit. The last one was, I believe, the other cone one had an answer that was none of these. Although 7 people got this right, so maybe I'm wrong on that one. Not having an answer. Just like I was wrong about this one not having an answer. But the last one definitely was super whack. Here. So question-wise, let's roll through this list and see what we got. Okay, Valak asks for questions on implicit, and I have some handy-dandy implicits from an old review I used to use somewhere in one of these files. So I'm going to open that up. Do I really even need that? No, let's not be a quitter. Let's just wing it. Alright, so implicit's fairly easy to review because the questions are so similar all the time. So let's do the really horrible kind, like this. Here, this is sufficiently awful. Let's make this even harder to pull apart. This looks like a pretty horrible. And did I make it too high up? Oh yeah, I totally made it too high up. Good thing I have the stream open. Can I grab this and move it down? Am I smart enough? No, I don't believe in myself. Alright, the question I wrote up there was xy sine x equals y minus 2 over x plus 1. Which now exists. Okay, so if I want to take the derivative of this function, here I have a triple product rule, so that kind of sucks. And by kind of sucks, I mean it really sucks. So let's take that derivative. Derivative of x is 1 times the other two things, plus the first thing times the derivative of the second thing times the third thing, plus the first two things times the derivative of the third thing. Cool, that's the left side. On the right side, we have even more issues because we got a nice little quotient-y bud here. So we have bottom d top minus top d bottom all over the bottom squared. Oh, big yikes. What did I do to myself here? This looks sufficiently horrible. Lord of Goshen. Okay, so I need to extract the dy dx terms from the other terms. So the first step in this horrible monstrosity is to multiply both sides by x plus 1 squared. So if I do that, I get y times x plus 1 squared times sine x plus x times x plus 1 squared sine x dy dx plus x times x plus 1 squared y cosine of x equals x plus 1 dy dx. And here I can just pull these terms apart, minus 1 plus 2. Yeah, this is horrendous. I have created a monster. Okay, but now we get to the nice part, and here's where I start doing a lot of things manually. I'm gonna move this stuff over to this side, and then I'm gonna move this dy dx term over to this side, and that's gonna clean everything up as far as the process goes. So on this side, I get all of the things that don't have dy dx. So I get like this one and that one. And the plus y minus 2 from the right side of the equation. And then on the other side, I get the dy dx, but I'm going to factor it out of the two terms that I moved over here. So I get an x plus 1 from here. And I get the hello? Okay. Sorry, guys. I do not know what is up with OBS right now because it's not even picking up when I'm not plugged in. So my internal microphone on my thing isn't even picking up. So it's almost definitely an OBS issue. To look back at this problem here, all I did at the end here was divide by all the crap that was multiplied here, and Nick, I did get that question right. It was a y minus 2 because I'm adding y and subtracting 2 to move this over to the other side. So I'm pretty certain that is correct on that question. So even though this is a horrible monstrosity, matching this as to another multiple choice probably would not be that hard because, yeah, you just get to this point and you're like, oh, it's the one that looks like this horrible monstrosity. All right. Yeah, folks, I'm probably gonna do Kennedy. This is way too confusing to be helpful. I'm not even entirely sure that's true. Triple product rule, great review for a quiz. Here, quotient rule, good review for a quiz. Multiplying the x plus 1 squared term to the other side just means each one of these dudes has an x plus 1 squared in it. And then just getting the dy dx terms on one side, getting the other terms on the other side, and solving. That's every one of these, no matter how simple you make it. I can make one way easier just for giggles before I get to the questions on the review that Chinmaya was asking about. Here's a really easy one. X sine y equals 2. You take the derivative with the product rule. You get the dy dx terms on one side and the other crap on the other side. So same exact steps, just less writing because there's fewer terms. And you divide by the stuff that is multiplied by dy dx, and you're clean there with implicit. So this is a very simple implicit compared to the very complex one on the previous piece there.